It has been quite a while since I have sat here at the desk with an inverter and talked to you about the gradual progress I've been making on making my Morris Minor electric. So today I'm just going to run you through where we're at. I'm going to explain why I'm excited about blinking lights, and we'll get down to brass tacks about what happens next. The project has taken quite a lot longer than I hoped to get going, and that's partly due to my own lack of knowledge, it's partly due to some problems I've had, and it's partly just due to time. To give you a quick recap, I have been planning to build a conversion of my Morris Minor using the open inverter board from Damien Maguire. This is an open inverter board, and it's installed in a Toyota inverter from a Yaris or some other small Toyota vehicle like a Toyota C, Prius C. And you might be thinking, well, that's great for driving a hybrid engine, but what you can actually do with it is you can fit one of these boards to it and you can convert it into an inverter that can drive an electric motor. The process has been a little bit more involved than I was expecting. I think I didn't really understand at the beginning that the instructions on the wiki still need a lot of work, and I've been putting in a little bit here and there just to try and help clarify some things as I've gone through them. But it's an open source project, so anyone can chip in, and I know that documentation is often the weak point of open source projects, and so it has proven for me, along with my lack of experience, which quite honestly has been responsible for a number of problems. The first of which was the first inverter. See, it's difficult to tell when it looks like this, but this is not in fact the inverter with which I started. I got my first inverter. It was actually a little bit more battered than this one, cost about the same. And then I stripped it down and started to do something which is required for running the inverter at higher voltages than it was originally designed for. In the lower half of the body here, there are some capacitors which operate at the voltage of your battery. And in this, they'd be running right at their limit. And other people have found that they go bang. And prior experience with other vehicles tells me that going bang is bad. I mean, outside of suck, squeeze, bang, blow, which is bad anyway, I guess. So I decided that, someone else had already done much of the work about how to change those capacitors. So I thought, can't be that hard. Finding the capacitors, that took a little while. There aren't any specs published, so I had to kind of take a best guess stab at it. And then finding a capacitor that I could buy in units of less than 10,000, that took quite a lot longer. When I eventually decided on capacitor, got it sent to the house, arrived, I set to trying to remove the original capacitors from the board. And behind me you can see an array of tools. And I started off with my rework station, trying to heat it. That didn't work. I have a really basic Weller soldering iron. Tried that. That didn't work. And then eventually what I settled on as an approach, which oh so nearly worked, was using the rework gun and the Weller soldering iron to heat the pins up. Problem is the ground plane on that board is really huge, and getting the pins hot enough to remove the solder, I just couldn't do it. But using those two together, it seemed to be working, and then I managed to delaminate the board. That was an expensive mistake. I did spend a little bit of time considering whether I could just kind of work around it, but it's a multi-layer board and I didn't know whether there were other layers that were damaged. It just, the idea of building the whole car up and then having it go bang for that stupid reason for a $60 part just wasn't worth it. So I then went to get another one, and unfortunately in the interim the price of inverters had roughly tripled. It took me a long time to one, decide that I was willing to pay much more than I did the first time, and two, find a reasonably cheap one that would ship to me. Again, I've found that breakers often have no interest in shipping to individuals. So it took me a while. I finally got this inverter. And at the same time, I ordered one of these, which is a desoldering gun. I think it's about 150 watts, this soldering iron. And it also has a vacuum which switches on when you pull the trigger, and a little hollow tip on its soldering iron, on the soldering iron end, so it can suck solder directly off. Using that, removing the capacitors was easy. That is the best $100 I have spent on tools for a long time. It was awesome. Then I managed to replace those capacitors. You also have to replace, I think it's 4 resistors. That's all documented in various places in the wiki, the forum, and then there's also a little video on the internet of someone doing it. Got that done, put it back together, and then Oakmar said you really shouldn't use hot melt glue, which is what I'd used to just fix the capacitors to the board. They were soldered in, but the hot melt glue was supporting them. So I stripped it back down, having ordered some special silicone glue that's used for circuit boards. I stripped it back down, put that on instead of the hot melt, well, kind of mainly as well as the hot melt, because I couldn't get all of the hot melt off, and then reassembled it a second time, or a third time. It was some number of times. It took a lot of times. Then we got to the open inverter side of the board. Building up the open inverter was great. Followed the instructions. It worked perfectly. Basically, first time, turned it on, did exactly what it should, got blinking lights, great. Then came doing this side of the inverter, and that is actually the thing that took the most time, because separating the two halves was incredibly difficult, at least for me. I tried brute force, I tried putting some bolts through with spacers to try and force the two halves apart. The problem is this here isn't cast alloy casing, so you don't want to be hitting it loads because it can crack. After quite a lot of time, I'm talking, I think, over a month of me just occasionally coming out, attacking it for 20 minutes, and then being like, yeah, I'm not getting anywhere and I don't want to break this, I decided to try a few other things. I got hold of some solvent, put that on it, didn't really do a lot. And then I had the great idea of just using a heat gun. So I differentially heated it. I heated the top and near the seal with the heat gun, not an enormous amount, and left this bottom half, which has a big casting on it, cold. I didn't actually have to heat it that much. I mean, it helped, I think, that it was a very cold day when I came out to do this. And that differential heating and softening of the glue, that was enough. I got it apart in a few minutes. I wish I'd thought of it earlier. It went really well. There's a tip for you all. If you're trying to split a Toyota inverter, a heat gun on one half, just gently. You don't have to do a lot. That was enough. And it basically just popped apart with no hassle. Changing the board is very simple. swapping the board over is basically unplug a few things, undo a few bolts, pop the new board in, which has gone great. So with this board replaced, the next thing that you need to do is replace the connector that comes out of the end of the inverter. This is the original Toyota main board. Now that is because this connector here is not available off the shelf. They won't sell you it. And so while I could get a harness from a Prius or a Prius C, whatever Toyota I went and pulled it from, unfortunately, getting it is really expensive. Like the inverter itself was $50. The cables I've not seen below a couple of hundred, if I've seen them at all, because usually scrapyards just pull the cables and chuck them. They don't care. And trying to persuade them to dismantle a car and get that for you, that is really hard. Now, in other places where you take the car apart yourself, it might be easier, but most places that you can get Prius spare parts for, they dismantle the car for you, probably because of the high voltage components and the risks inherent with that. So the solution that the Open Inverter team, and mainly Damien Maguire and Johan, have come up with is this, which is a daughter board, which you install an amp seal connector on, which is great. The only slight problem is that every time I've tried to order it, it's gone horribly wrong. So there are a bunch of 3D printed parts that you can use to replace that connector, along with a connector that you can just buy off the shelf. This, for example, is one of them. Excuse the quality of the printing. I changed the spool on there and didn't bother to change any of the settings. It's going in a car. I don't really care. I'll clean it up. But this goes on the outside of the inverter, and then inside that is an amp seal connector. And an amp seal connector is something you can just buy one-off off the shelf from, say, Mouser or DigiKey or wherever. And it has a component that goes in the car that goes outside the inverter. This is the side that plugs into the amp seal connector. The other half has been a little bit tricky to get hold of. So this is a 90-degree amp seal connector, because I ordered not one, but two of these. And there were two listings for it on, I think it was the Mouser website. One which said 90 degree and one which did not say 90 degree. I looked at the other one, looked at the datasheet and went, oh, that's the 90 degree one. Went back, clicked on the other one which didn't say 90 degree and ordered it. And then it arrived and it was another 90 degree. But I've spent a long time trying to get hold of the right one of these. It's made more complicated because they are pairs. So this one is not a match pair, and they don't go together, and they won't fit together very well. Just because it's the two scrap ones I pulled out. I have spent a long time looking for a matched pair that was under $100. Eventually I found a company in China that is shipping me one, and that's why we are stopping at this point for the moment, and you're not seeing it full and complete and closed, because I am waiting for a connector to arrive from China, because no one that I can find in the US has these. Now, whether they're real amp seal connectors or knockoffs, I don't know, so we'll find out when it arrives. But it was only $40 for the pair, which is slightly more reasonable. So that held me up for quite a while, because I was waiting optimistically for me to find a solution to this, and I kept ordering them and then they'd turn up. I went through it twice, but I ordered them and then it would take a few days and it would turn up, and then I'd have to wait until the day when I was free, and yeah. And then I learned that I needed to look in the container before I waited. Unfortunately, then we come to my next moment of truly epic stupidity, and I can't really overstate how foolish this was. I was overexcited. I was like, I am so close to getting this working. And what I have here is the evidence of my stupidity, which is the daughter board that should go roughly here. This daughter board carries the amp seal connector. This is a very sad daughter board. I'm going to have to run quite a lot of wires to fix it, because I got very excited. And I don't quite know what possessed me. I spent like days ahead making sure that I had down what I needed to do when I came out to the garage, because I have a limited amount of time. I had it in this state, but I hadn't tested it powered on to see if the signals that you can find here, which tell you that it's working, were there. I hadn't connected to the Open Inverter wireless network, which this device here generates a wireless network so you can connect and configure it. I hadn't tested it in the inverter itself. So that was the next step. And I spent a lot of time reading up on the forums and having a look at what I needed to do. And then I came out and did something atrociously stupid. So I thought I had the pinout in front of me for the amp seal connector. And so I soldered some wires on just on the back very carefully to provide power to what I thought were the pins that I should have done. And then I connected the power to this daughter board and smoked part of the daughter board. Thankfully, what I did is actually I connected the power straight to ground. Nothing smoked on the board, and the board is still telling me everything is working, so I believe it's working. I have to run a whole bunch of wire on this to make up for the error. If you're wondering what this is a fly lead to add a resistor in that's missing on this generation of the board. Yeah, I need to rerun the ground pins because I basically toasted all of the ground connections on the board. In fact, you can actually see that they're charcoal instead of anything nice, which is let's say it's a distressing state of affairs for someone who likes to think that they know at least vaguely what they're doing. But I'm not above admitting stupidity, so in future, no, don't do that. So that brings me to what's next. Well, part of what's next is waiting for this connector. As soon as I get that in, there's a couple of other things I need to do. This wireless daughter board, ideally I should move out onto something outside the inverter casing, because unsurprisingly the inverter casing acts as a big shield and you can't really get the signal out. I've got a whole big pile of 3D prints to clean up, so that's one of the tasks to do over the next few days. And mainly these are things that go outside or on the inverter, that are plugs for the holes in the casing that we're not using, things like that. Now, the other thing I need to do is, just like the inverter connector is made of unobtainium, so is the connector on the motor. It's actually discontinued. I mean, the motor is getting on for 10 years old, so it's not entirely surprising, but even when it was available, apparently it was tricky to get hold of. So I have these, which are automotive grade connectors, which have a little seal in them. And so the plan is there's a 3D printable part that you can use to replace the existing connector on the motor. And then I'll put just a cable coming out of it with this dangling off it. And then we'll be able to connect the motor up. And then, and this is quite exciting, I should be able to use this to make the motor turn. And that's when things get fun. So, the next video should be this assembled, powered up, and connected to a motor with the motor spinning. Other people have done some of the work that I need to do there as well. They've identified some of the things about the motor that I need to know to get it connected up and working. I'm really quite excited. I've let myself get one step ahead. I've bought some connectors so I can knock myself up a quick power supply to drive the motor, which will hopefully be like 40-ish. 36 volts. It'll be 3 lead acid batteries from a scrapyard is the plan, with a current limiter and things like that in line. But I'm really looking forward to it. I'm really excited, but also I'm aware it's probably going to be quite a while until the next video. So looking forward to seeing you all next time. that's it for today. Thank you so much for watching. I hope you've enjoyed it, and I'll be back with more hopefully soon.